Hello guys, welcome to another video. In this video I am going to share the solutions to problem C1 and C2 of the Facebook Hacker Cup. So without any further delay, let's get started. So in problem C1, second meaning, we are given that Morse code is a classic way to send messages where each letter is an alphabet and is substituted with a code word, a unique sequence of dots and dashes. However, ignoring spaces, it is possible to create a coded word message having multiple meanings. For example, like this, as it's given in the example, this sequence of dots and dashes is giving two meanings, that is hacker cup or C meter rent a van. So what we have to do in this question is that we have to create our own coding system, which they are naming as beyond Morse code, where a general set of code words which without spaces will always give an unambiguous encoding if any possible sequence of dots and dashes corresponds to either 0 or exactly one sequence of code words. So what the problem statement is saying, that similar to Morse code, we have to create our own coding language or a code system in which however we place the dots and dashes, there will be only one way to interpret its meaning, right? So for example, in Morse code, say if we put dots and dashes like this, so there can be multiple ways of interpreting this. So let's say we take this first, then dash and dot, then we take this pattern, and then we take this pattern, or we can take this, or we can merge these two, and then we can continue with this again, this again. But we have to create a unique system of code words. Say if our sequence is this, then it can be interpreted in a single way like this. There will be no code words, so which will confuse its meaning, or there will be no other ways to group. So this will not be a valid arrangement, right? So let's analyze in which conditions can a set of code words result in multiple meanings, right? So for example, if we take the example of Morse code, for example, S is this and E is this. So let's say if we have a string of dots and dashes like this, so the first part, say there is also another alphabet which can be interpreted something like this. So it can be grouped like this, then like this, a set of three dots and a set of two dots, or we can also do it like this. So we group these two together, then this dash. Now we can group these two also as well. So this will become E. Say we name this as something alpha, and then S and E. So we name this as beta, say this as gamma. This will become E and S. So here alpha, beta, gamma correspond to some letter of the alphabet which has this sequence of Morse code. dashes as its code word. So what we can see is that it will only have multiple interpretations of the same word only when there is some common prefix coinciding these code words. For example, let's say we take the example of S and E, then a prefix of length 2 is common to both of them. So if we have a string of dots, so we can interpret this entire length as differently. So we can name this as either a set of two E's, or we can interpret as a set of three dots and one single dot which corresponds to I. Right. So how do we remove this? So how do we come up with a set of code words which will always correspond to an unambiguous meaning? So turns out the main observation is that we can make our own system of code words having the same length. Say a length of 6, and if we permute them 6 factorial ways, each of these code words will be distinct, and even if we take string of z dots and dashes, there will be only one way to interpret its meaning. Say for example, if we take a simple example of length 3, so let's take all the code words possible of length 3 having the same length. So if we permute them in this fashion, so this generates our system of code words having 8 such code words which can be interpreted in only one way. So if we take this string for example, so each time we have to take a length of 3 of this sort, and each of these words are unique since this let's say these 3 factorial ways, or let's say it's 2 to the power 3 ways, since each place can either be 0 or each place can either be a dot or can be a dash. So if we arrange them in this way, so we can see that there can never be two same arrangements of the same type. Like we always have to start from the beginning and take a length of 3 and continue taking further. If we try to group these 4 together, it will become invalid and it will have no interpretation from the system of code words that we develop. So the simple solution to building a system of n code words is to try and have them of the same length. But in this question, one code word is already provided to us, say of the type like this. So we have to ensure that the other code words that we develop should not have any common prefix to it. So we can treat it very simply. For example, if the first dot is, so say that if the first character is a dot, we can change it to dash, right? So the prefix becomes different, and now we can build the rest of the string as we desire. There is no constraints to how we can build the remaining strings, and they should be of the same length, right? So the main difference between the two problems, that is C1 and C2, is basically the difference in the length of the code words which it can take. So in the problem C1, the maximum length that each code word can take is 200, and in C2 the maximum length that the code words can take is 10. So let's try to build a solution for a maximum constraint of 10, which will imply that C1 will be solved automatically. So let's see how can we develop code words of having a maximum length of 10. So just like I explained, so if the first one code word is given to us and we cannot take the same prefix as that. So if the first character is a dot, we change it to dash or vice versa, right? So after we have that dot, so the rest of the string is free to us, and it can have a maximum length of 9. And in the question it's given that n can have a maximum value up to 100. That is, we have to build a system of code words where there can be at most 100 different code words, right? So what should be the minimum length so that we can create our coding system of a length of at least 100 or at most 100? So it turns out if we take a length of 7, we will always satisfy that n equals to 100 criteria, since we generate all possible arrangements of dots and dashes. So each position, say the 7 places, each position can have only two choices, which is a dot or a dash, and so on, which will give a total of 2 to the power 7 options. 2 to the power 7 options, or a total of 2 to the power 7 different code words, and 2 to the power 7 is equals to 128. So in each of these code words we can simply append this dash or a dot depending upon the code word which is given to us. So basically, say if this is our first code word which is supplied to us, we can simply change the first character as dash and append to each of the 2 to the power 7 options that we obtained, right? And in this way we can generate all the n words, which will not only have the same length but will have different prefix to the supplied code word and will always yield an unambiguous meaning. So let's see the code quickly, which will help us to analyze the solution better. So firstly, in this part, we create a vector of strings and we try to generate all the 2 to the power 7 string options which we'll get. That is 128 options which we will get. So this is the generate function where we are trying to generate all the possible strings, and then we are storing them in this vector A. Now for each test case, we check whether the first character is a dot, then we take the first character as a dash, or else we take the first character as a dot. Now for the first n minus 1 options of our, say, the array A which we have generated for all test cases, we simply append the first character to each of the first n minus 1 strings, and that will be our answer, and we simply output all those strings which we obtain. So if we try to run it for test case, we will get a case like this. So in our first test case, we have a dot dash dot. So we append a dash to our string, which is the first string which we are getting from the array A we generated of this type, and the second string. If we have a single character of this fashion of only a dash, we change the dash to a dot and append to the first three strings from our stored array, the array A, like this. And in this fashion, we can build our strings or the n-1 code words for all the test cases that is applied to the question. So this was the solution to C1 and C2 of Facebook Hacker Cup 2022 qualification round. So if you have liked the video till now, do like, share and subscribe and press the bell icon to receive more such updates about CP related stuff from my channel. Thanks for watching.